Now let's go through an example. The question says calculate the number of grams of potassium sulfate and water produced when 14 gram of potassium hydroxide is reacted with an excess of sulfuric acid. Also, calculate the number of molecules of water produced. So, as we can see, there are two parts to this question. The first one requires us to calculate the mass or number of grams of potassium sulfate and water. And the second one requires us to find the number of molecules of water. Correct? Before starting any calculations, we first need to convert the mass of potassium hydroxide into moles and then compare these moles with that of potassium sulfate with the help of a balanced chemical equation. This simply means we need to construct a balanced chemical equation before we move further, because if you can recall, that is one of the conditions of stoichiometric calculations, right? In the question, we have been given the mass of potassium hydroxide, which is 14 grams, and we know how to calculate the molar mass of potassium hydroxide, which would be 39 plus 16 plus 1, which is equal to 56. We just added the atomic masses of potassium, oxygen and hydrogen, which gave us 56. Using these two values, we can easily calculate the number of moles of potassium hydroxide. It would be mass of potassium hydroxide divided by molar mass of potassium hydroxide. That would be 14 divided by 56, and we get, yes, that is right, 0.25 moles. Once we have the number of moles of potassium hydroxide, let's have a look at balanced equation for the reaction taking place between potassium hydroxide and sulfuric acid. 2KOH plus H2SO4 gives us K2SO4 plus 2H2O. Using this equation, we are going to find out the number of moles of potassium sulfate that are being produced from 0.25 moles of potassium hydroxide. So guys, in the equation, you can see that 2 moles of potassium hydroxide KOH give us 1 mole of potassium sulfate. Isn't that correct to say? Using simple mathematical ratios, we can write 2:1, right? Then 1 mole of potassium hydroxide will give us 1 divided by 2 moles of potassium sulfate, and in the same way 0.25 moles of potassium hydroxide will give us 0.25 divided by 2, which is 0.125 moles of potassium sulfate. Now at this stage we have the moles of potassium sulfate, isn't it? Now we can easily calculate the mass of potassium sulfate, which is the first part of our question, right? Mass of potassium sulfate is equal to the number of moles multiplied by molar mass. Let me add here, we have discussed molar mass so many times that it won't be wrong to admit that we know how to calculate it fluently by now. So it is going to be 2 multiplied by 39 plus 96, which is equal to 174 grams per mole. Now multiply this 174 with 0.125 moles and we get the mass of potassium sulfate, which is 21.75 grams. This brings us to the end of the first part of our question. The second part of the question requires us to find out the number of molecules of water using the same balanced equation and ratios. We know that 2 moles of potassium hydroxide give us 2 moles of water. So 1 mole of potassium hydroxide will give us 1 mole of water and 0.25 moles of potassium hydroxide, which will give us 0.25 moles of water. So the number of moles of water produced is 0.25 from 0.25 moles of potassium hydroxide. Next, the mass of water can be calculated by multiplying this number of moles with the molar mass of water, which would be 0.25 into 18, and it gives us 4.50 grams. In the end, what is left behind to find out? The number of molecules of water. It is very simple to calculate that with the help of Avogadro's number. Multiply the number of moles of water that is 0.25 with the Avogadro's number that is 6.02 into 10 to the power 23, which gives us 1.50 into 10 to the power 23 molecules of water.